What if I told you that you already speak a secret language? It's true. It's a language of patterns and problem solving that you use literally every single day, and you probably don't even realize it. So, in the next few minutes, we're going to crack that code together. Okay, so let's just jump right in. Take a look at these pretty normal everyday activities. What do you think possibly connects all of them? I mean, really think about it. When you hop in a taxi, you're already doing the math in your head, right? You're calculating the fare based on how far you're going. Or you're wandering down a grocery store aisle and you're adding up the cost of everything in your cart. In both cases, you're trying to solve for an unknown, that final bill. Or hey, maybe you're at a fruit stand. You see the price per kilogram, and you're kind of eyeing that big pile of rambutans, estimating what it's going to set you back. See? In every single one of these situations, you're using a system to figure out a value you don't know yet. Well, that system, that secret language, is algebra. Yep, that's right. You've been using algebra all this time. It's really just a powerful shorthand, a way to describe patterns and figure out the unknowns in life. So if algebra is a language, then it's got to have some basic building blocks, right? We have to start with the fundamentals. Let's learn its alphabet. In algebra, the alphabet is all about variables. Just think of them as letters. You've seen them, X, Y, or Z, that are basically just placeholders. They stand in for a number we either don't know yet or a number that could change. For instance, if you don't know the exact price of a kilogram of rice, you can just call it X. See? X isn't some scary, complicated thing. It's just a little label we stick on that number until we can figure it out. It's our unknown. Now, once you have letters in a language, you can start making words. In algebra, we call those words terms. A term can be super simple, like just a number or just a variable, but most of the time it's numbers and variables multiplied together. Let's go back to that fruit stand. Let's say you sell 350 rambutans, and the price for each one is our unknown X. The total amount of money you make is just 350 times X, or as we'd write it, 350X. Boom. That's a term. It's one neat little package of information. And get this, in that term, 350X, the number part has its own special name. The 350 is called the coefficient. And all that fancy word means is how many of the variable you have. So in this case, we have 350 X's. Simple as that. Okay, quick recap. We've got our letters, the variables, and we've got our words, the terms. So you know what has to come next? It's time to start writing sentences. These sentences are called algebraic expressions. And really, they're just combinations of our terms, our algebraic words, all strung together with plus or minus signs. They just let us tell a more complex story. Let's go back to that taxi ride. There's a fixed starting fee, right? 100 rupees. That's our first term. Then they charge 50 rupees for every single kilometer, which we're calling X. That's our second term, 50X. Put them together, and the total cost for your ride is 100 plus 50X. That's an algebraic expression. It's the complete story of your taxi fare. All right, you ready to level up? Let's try one that's a little more involved. Imagine you're at the store. You're buying 2 kilograms of rice, and the price per kilo is X. You also grab 500 grams of sugar, where the kilo price is Y. And then you grab 250 grams of flour, where the kilo price is Z. And here is where it all comes together so beautifully. We can write down that entire shopping trip is just one single sentence. The total cost is 2 times X for the rice, plus half of Y for the sugar, plus a quarter of Z for the flour. See, this expression isn't just a bunch of math on a page. It's the complete story of your purchase. Okay, so now we know how to write a sentence for one shopping trip. But what happens when you need to scale things up? Well, this is where multiplication really starts to shine. So, picture this. You're making gift parcels. Each parcel has some unknown number of books, let's call it X, and an unknown number of pens, Y. So one parcel is X plus Y. But what if you need to make 8 of them? Here's how it works. You don't just multiply the parcel as a whole. You have to distribute that 8 to everything inside it. You gotta share the love. So you multiply the 8 by the X books, and you get 8X. Then you multiply the 8 by the Y pens to get 8Y. So the grand total is simply 8X plus 8Y. Now, there's a really important rule here, so listen up. When you multiply by a positive number, like with 2 times A plus B, everything's easy. The signs all stay the same, and you get 2A plus 2B. But, and this is key, When you multiply by a negative number, like -2 times a plus 6, it flips the sign of everything inside. It becomes -2a minus 12. You gotta watch out for that. So we can multiply our sentences by a number. But what happens if you need to multiply them by another algebraic word, another term? Well, one of the best ways to actually visualize this is with something we all know, the area of a rectangle. This diagram just makes it so clear. The total length of the rectangle is x plus y, and the breadth is a, so the whole area is a times x plus y. But you can also see it's just two smaller rectangles put together, right? One has an area of ax, and the other has an area of ay. So a times x plus y is the exact same thing as ax plus ay. It's that same distributive idea we saw with the gift parcels. And just like that, you've pretty much learned the fundamental grammar of this so-called secret language. You've cracked the code that's been hiding in plain sight this entire time. So let's recap one last time. Variables, they're just the alphabet. Terms, those are the words. Expressions are the full sentences. And these sentences, they are incredibly powerful tools for describing the patterns that make up our world. You know, you probably came here thinking you were going to learn about algebra. But the truth is, you were already speaking it. So my question for you is this. Now that